Hello everyone. Can you hear me? Can you see me? Write in the chat box. Am I audible? Still don't know. Okay, you can just write yes. Okay, I think some people are saying hello, hello. So I mean that I'm visible. Okay, good. Okay, good. So I am visible, I am audible. Okay, so let's go. So first of all, clearly audible, also audible. Good, audible, visible, everything is there. Yes. Yes, can someone say yes to both my questions? Yes, okay, I got the picture. Okay, so let me share the screen now and let me go to the document and show you. Okay, so first of all you have got reach the finish line of your IITJEE prep. Start date March 28, ended this one, back on learners demand. You see there is 1 month extension and 3 months extension, all those things are there, so you can check those offers. Then you have got let's crack JEE Mains, date and time March 30th is 2022 9 p.m. webinar highlights, you can see this one. So it will be good for you and people to attend this seminar, so do attend the webinar. Then batches starting, Yalgar batch, quick concept revision batch and early evolve batch. You can check it later and you can tell the people who really need it, they can join. Unacademy Lite offer is there. All India online test series for JEE Mains and advanced. Know where you stand, you can check all those things. Up to 23 tests you can take. You can use my code AlokSirLive, and then of course you can check. Okay, now let's go to this one. Other then. For those who might have come late or they do not know me, you can follow me on Unacademy. I am Alok Kumar, B.Tech from IIT Kanpur, and I'm an INMO medalist. And I have experience in teaching both IITJEE and Olympiad mathematics. You can check later things earlier at your pleasure. I've been proposing problems in magazines also. And then you can check all my classes, AHA lectures by me, and you can check the tracker, and my classes are happening all the way. Okay, then let me start today's topic. So today it is about, let me add something. Today it is about integration, right? So as you know that this integration, when you say, you get both kind of definite integration, definite, and you get indefinite also in JEE Mains and advanced, right? These days what is happening is that because normally questions are multiple choice questions, आंसर दिए होते हैं वहाँ पे, तो they try to ask even indefinite question also, such that you want to get some value, right? ये उनका strategy है, so that you don't blindly guess the answer, right? To discourage you. तो ये हम लोग करते हैं उसमें, right? तो तुम देखोगे ऐसे examples. Again, some themes like those kind of thing often occur. So I can say that finding unknown function, or say Leibniz rule, or maybe that effective use of definite integration limits rules, those things are pretty much always asked. So uspe I have taken some sample problems, the beautiful ones, the most beautiful ones. So I hope you will enjoy them. So let's start one by one with them, right? So these are the common things. अब तो चूंकि JEE Mains आने वाला है आपका, तो I am sure that everyone is practicing problems. So I have also attempted to give you some problems which really will tell you where you are there, right? The best that has ever been prepared or something. Okay, now first is this one. E to the power 2x plus ये देखो ऐसा है 2 e to the power x minus e to the power minus x minus 1 times e to the power c, e to the power e. That's like tower of powers, right? So you might be amused कि क्या है क्या ये gx, है ना, ऐसा पूछ रहे हैं वो. So basically it's a question of indefinite integration, indefinite, मगर कुछ वैल्यू चाहिए उन्हें, तो दे हैव आस्क्ड यू देन g0 इक्वल्स व्हाट इज g0, लाइक दैट मीन्स gx को तुम्हें निकालना है ना, करेक्ट. तो g0 you have to find. Let us see how I can find this one gx. तो e to the power 2x plus 2 देख रहे हो इसमें, ये ऊपर है e to the power x. So let me do this way, that let me write it first so that I can correctly start writing. So I add the page. So ये e to the power 2x, e to the power 2x plus e to the power plus 2 e to the power x. So we have got e to the power 2x plus 2 e to the power x. You have to integrate this one, 2 e to the power x minus e to the power minus x minus 1 e to the power ex plus e to the power. See this big bad thing, right? तो पहली चीज तुम ये देखो यहाँ पे कि e to the power x plus e to the power minus x, अगर ये आपका fx है, suppose this is your fx, suppose this is your any function ax some function on top, तो you know that a prime x ये आपका आ गया e to the power x minus e to the power minus x, right? देख रहे हो ये, तो e to the power a is there, तो a prime x is this. I will try to find this kind of thing कि ये कैसा आ सकता है, कैसे कर सकते हैं इसको. Okay, so what I will do that I will break it. So I will, ये मुझे पता है कि ये a prime x ऐसा आएगा, right? तो using this one what I am writing that it is not even odd, it's not a question of even odd. Okay, all of you can try that question instead of guessing the answer or asking about that where it exactly came. Okay, right? So I think that does not do any service. No, the way is that you please answer the question, think it, and then just check it that you're able to do it or not. It's a good question. That's what I can tell. Really beautiful question. No, it is enough to scare a student कि अरे भाई ये बहुत सारा e to the power x है, ये ऐसा है वैसा है ना. Now see, मैं इसको ऐसे ऑर्गेनाइज करता हूँ इसको. I will do by parts here. So I will organize my work. I will write e to the power 2x. I will write e to the power 2x plus 2 e to the power x minus e to the power minus x minus 1. इसको मैं ऐसे लिखना चाह रहा हूँ. I'll just write this. So this I want. See, minus x I want, right? Minus x I want, correct? Yes. So I can write this e to the power 2x plus ex minus 1 plus e to the power x minus e to the power minus x, right? This thing I have written like this, e to the power plus of this one. So this e to the power x, e to the power 2x plus, so it is e to the power 2x plus e to the power 2x I will write plus e to the power x minus 1 and plus e to the power x minus e to the power minus x. ऐसा मैंने लिख दिया. अब देखो तब मेरा I क्या बन गया. This I becomes integral, और इसको मैंने ब्रेक किया e to the power 2x plus e to the power x minus 1 times e to the power x plus e to the power minus x and plus e to the power x minus e to the power minus x e to the power x plus e to the power minus x dx, right? This way I did. Are you getting my point? This way I did. Now what I can do here. So here मैं ऐसा कर सकता हूँ. देखो क्या मैं कर रहा हूँ यहाँ पे. I will take e to the power x out here. Let's see what good it does. e to the power x यहाँ out हो गया, यहाँ पे देखो, यहाँ पे, और यहाँ जो बच गया तुम्हारा वो हुआ e to the power x और minus e to the power minus x and plus 1. See, I moved this here, plus 1, right? e to the power x plus e to the power minus x dx and plus this part is there. This part e to the power x minus e to the power minus x or e to the power x plus e to the power minus x dx, right? This part is there. है ना? कोई doubt, any doubt till here? Again this one and this one, इन दोनों को मैं combine करूंगा because I have got this one over here, this one over here to take care of. तो मैं लिख सकता हूँ इसको integral e to the power x minus e to the power minus x plus 1 times e to the power, और top पे e to the power x plus e to the power minus x and plus simple x. This x gets added here, plus x. I hope this is clear. And plus this thing, right? Now you see, no need to differentiate. Now you see that this is the complete integral, right? This is because if you put here this one in first one, if I put for the first one, I'll put e to the power x plus e to the power minus x plus x equal to u for first one. Then I will get I equal to integral. This is e to the power u and du, exactly what you du. See, this much u, and plus, and I can also put v equal to, and I can put v equal to e to the power x plus e to the power minus x. So I'll get this times e to the power v, and this is dv, right? So I'll get e to the power u plus e to the power v, right? E to the power u plus u to the power v, I get uv, e to the power u, u to the power e to the power u, and e to the power v. So now my job is done. So my answer is e to the power, and u, so e to the power x plus e to the power minus x plus x, and times e to the power x plus e to the power minus x. तो मैं इसको ये कर सकता हूँ, I can combine them, and I can write finally as e to the power x plus 1 times e to the power x plus e to the power minus x. This is my answer. And they are saying, you can check it, they are saying gx times, this has come up gx times. So compare करो पे gx तुम्हारा ये, this is your gx. So it means your gx becomes e to the power x plus 1, giving you g0 equals 2. Let's check it. What I did कि इसमें मैंने आपको दोनों तरफ ब्रेक कर दिया, मैंने ब्रेक किया, केयरफुल ब्रेकिंग, डिपेंडिंग ऑन ऊपर क्या है ऊपर. This I first thought about this one, that e to the power x plus this one is there. So let me, this is there, see, e to the power x to the power minus x, this is e to the power x to the power minus x. Then you have got this one. This I broke into two parts, e to the power 2x plus x minus 1, and e to the power x minus 2 power minus x, to take care of these thing. Okay, and then rest is routine. We got all the things. Is that clear? So final answer was this one. From here gx was e to the power x, and we wanted g0, so g0 will be equal to 2. So your answer will be that g0, your answer is that g0 equals to 2. This is what we found. Correct? Okay. Okay, now you come here. Okay, this is fairly easy. The integral x square dx is equal to, see, ये देख के ये लग रहा है तुम्हें, you can't integrate it by some substitution. So the only thing that it requires is nothing but by parts. By parts is the only hope here, because they are just jumbled up, no? X sin x plus cos x, मतलब कुछ भी तुमने मिला दिया है, कुछ भी है ना? So there is nothing like you are getting sine or cos or tan. Obviously any substitution is out of like mind. The only thing that is on your mind is that how to write it in the form of, say, by parts. तो उसके लिए मैं क्या करूँगा? First I will have to do some homework. ये x sin x plus cos x, ये जो चीज़ दिख रही है, let me say that let me ask that इसका differentiation कैसा होता है, prime, how the differentiation works इसका. तो like this is x times cos x and plus x times cos x plus cos x, x times cos x plus sin x, rather x times cos x plus sin x minus sin x. So you get something really good, x cos x. So this is very short, so I'll try to adjust that. So what I will write is this. Let me go to the next page. So मुझे निकालना है x square upon x sin x plus cos x whole square dx. So I try to create this, ये नीचे जो आपका फंक्शन u है, I try to create u prime in the numerator, obviously. So x sin x plus cos x whole square, and here I will let just x cos x, that's all. So it's like u and u squared. So it means that already this is there. I'll get x upon cos x, right? I'll get this one. Now my stage is set. I can take this as, say, first function and this as second function, this one, because I know how to integrate second. तो ये मेरा आ जाएगा, this I will take as, ये मेरा आ जाएगा x upon cos x, that is out, integral x cos x upon x sin x plus cos x whole square dx minus. Now x by cos x, ये हमें करना है differentiate, right? This is differentiate. So we differentiate this. So we'll get here, if you differentiate, I just write first x by cos x prime, differentiate, and this integrate. So this will get negative 1 by x sin x plus cos x. Do mind your signs, exam, important for exam, this one. तो ये आ गया नेगेटिव x by cos x 1 by x sin x plus cos x. That's all right. This you get, and this is now this is plus, and here अब यहाँ पे आएगा आपका cos square x. Here cos square x you are getting cos x, and this is minus x into minus sin x, so cos x plus x sin x, and 1 by x sin x plus cos x. So that nicely cancels out. That nicely cancels out. This nicely cancels out. So you get minus x by cos x times 1 by x sin x plus cos x, and plus you are getting simply tan x, right? So you can rewrite it as minus x sec x upon x sin x plus cos x लिख सकते हो, और plus tan of x, and of course plus lambda is lambda degradation constant. So you get this one. Okay, I will avoid red. Okay, red is not very much visible, people are saying, so okay, I will avoid red. So this is what you'll get. Got my idea? तो ये second problem है. This is also good, but it is easy. It is easier than the first one. Easier than the first one. This is good again by parts. Integral 1 plus x. So this is 1 plus x minus 1 by x e to the power x plus 1 by x dx. Again इसको इंटीग्रेट करना है. अगेन तुम्हें करना पड़ेगा ये बाई पार्ट सी. तो हेल्प क्या करेगा? x प्लस 1 बाई एक्स अगर u है मेरा, इफ दिस इज u, यू विल फाइंड दैट 1 माइनस 1 बाई एक्स स्क्वायर dx will be du, right? U prime is this much. U prime is this. No, let me write u prime only. U prime. So better notation, u prime is 1 minus x square. Correct? So I have to create somewhere. See, I see x is there, but if I take x out, I will be able to create that. You know? Whether this is useful or not, we'll see later. Just like this remarks, this question reminds you of this question. Correct? For the first one. No, the first one. This kind of thing, right? Something of ये जो top है numerator, that ये जो इसके e to the power e का. Now this prime is hidden here. This prime, मतलब e to the power x minus e to the power minus x is hidden here. That's what we are doing. Correct? तो ये something similar, and both have been asked. तो इसको मैं कैसे break कर सकता हूँ, right? तो what I will do, that I will write this as nothing good to show. So I'll write e to the power x plus 1 by x dx first part. And here I'll write integral, I will take x common, 1 minus 1 by x square e to the power x plus 1 by x dx, right? I broke it like this, and I wrote this one, 1 minus 1, because this is differential coefficient of this one, right? So I have to break it like this. Now, e to the power x plus 1 by x, इसी को मैं integrate करता हूँ. Let me integrate this using by parts. तो by parts integrate करोगे इसको जब by parts से, तो what you will get? You will get here, you take this as the first function, or this is the first function, correct? And second function is 1, simple 1. So you'll get e to the power x plus 1 over x, that's all right. Integral dx, okay, and negative. ये x आएगा, and this will be e to the power x plus 1 over x, and then 1 minus 1 by x square, right? So if this is there, then you are getting exactly the same thing. You are getting just this one. If you take out, right, exactly the same one. So this is negative sign, this is positive sign, they will cancel, and so result you will get as x times e to the power x plus 1 over x. This simple thing you will get, x times this one, right? So this is your answer to this question, x times. It is simple one compared to the first one. First one was really good. First one I will always like. Second, okay, second is normal, easy. Third is better than second, but of course is less trickier than the first one. Okay, let's move to the next one. ये routine है, this is routine, because it is just given in the form of tan. ये तुम्हें डराने के लिए या ये करने के लिए that ये tan का form है. Tan has no business here. ये तुम tan को break कर दोगे sin और cos में. So in fact ये आपका integral आ जाएगा 5 sin x, और आप sin x by cos x कर देंगे यहाँ पे, तो आएगा sin x minus 2 cos x. This is not given. Why? Because this is familiar form. ये familiar form, it is very familiar in this form. Familiarity is there. Here not familiar. You suddenly find here tan x है, पता नहीं tan है, cot है, we don't know what it is, right? तो ऐसा नहीं है, यहाँ पे जब ऐसे करोगे तो ये आ गया तुम्हारा कॉमन नॉर्मल फॉर्म। इसमें क्या करते हैं, दिस इज द जनरल फॉर्म ऑफ दिस इज a sin x प्लस b cos x एन अपॉन c sin x प्लस d cos x dx, राइट। मतलब ये m by n फॉर्म है, m by n, जैसा mn इस तरह के फंक्शन है। व्हाट वी डू हियर, वी राइट ऑलवेज m as in these things, we always write m, or we can choose n also, so we write m as lambda times n plus mu times n prime। मतलब तुम एक्सप्रेस कर रहे हो न्यूमरेटर को, m को, न्यूमरेटर को लैम्डा टाइम्स डिनोमिनेटर प्लस म्यू टाइम्स डिफरेंशियल कोफिशिएंट ऑफ दिस वन, बट यही करना है केवल, वी हैव टू चूज कोफिशिएंट, रेस्ट विल बी टेकन केयर ऑफ। सो अगर मैं आगे पेज पे करता हूँ इनको जरा ये करके, तो ये इंटीग्रल 5 sin x एंड अपॉन sin x माइनस, और ये जॉब भी इजी है, sin x बट जरूरी है, 2 cos x dx। तो sin x माइनस 2 cos x प्राइम, इसको मैं f बोल रहा हूं, f प्राइम will be cos x and plus 2 sin x, right? So I have to write 5 sin x is lambda sin x minus 2 cos x plus mu times cos x plus 2 sin x. You don't want obviously mu you don't want sin x, तो तुम चुन सकते हो mu को, you can choose lambda is 2, lambda 2 or 1, I can choose 1, you can use because 2 cos x is there, lambda 1 mu choose, no, lambda 1 mu 2 is one such value which also works for otherwise proportional, lambda 1 mu 2 which also works for this because we got 4 and 1 5, so lambda 1 mu 2 works, so it means तुम इसको लिख सकते हो integral I equal to integral, let's call it f, so f dx, and this we are calling lambda is 1, we are calling it f plus 2f prime, so I am writing I equal to integral dx plus 2 times f prime over f dx, right? तो ये आएगा x plus 2 times ln of f, और ये अब लिख सकता हूँ मैं x plus 2 times ln of f, तो f आपका है वो चीज़ sin x, I can write mod, in fact mod we can write, so I'll write ln of mod इंटीग्रल इंडेफिनिट है, तो साइन पता नहीं अभी, ऐसा लिख देंगे अपने, है ना। तो दिस इज योर आंसर फॉर दिस क्वेश्चन, एंड यू वांटेड एक्चुअली सम वैल्यू, से दे गिव a, आई टोल्ड यू कि जितने क्वेश्चन रहेंगे ना ऐसे, वो सब दे विल गिव इन द फॉर्म ऑफ, yes, they give in the form of some this kind of thing where you have to find some value, otherwise you can simply differentiate. So this is a, so you will find that this a equals now 2, है ना, this a equals 2, so your answer is a equal to 2, a equal to 2 is the answer for this question. Okay, correct, easy one, very easy one, not a problem at all. Okay, f and g, it is very small integration, rather basically question is proposed differently. F or g two differentiable functions हैं, okay, on 0, 2 they are given such that f double prime minus g double prime is 0, f prime 1 is 2g1, g prime 1 is something for f2, right? This all will come later. So first of all we will start by saying that because f prime x minus g prime x is 0, this one I can integrate back. I will write f prime x minus g prime x is lambda, but given f prime 1, at 1 if you take f prime 1, put x equal to 1, so f prime 1 is 9 minus g prime x is 9 by 2, g prime x is 9 by 2, 2g prime 1, f prime 1 is 9 is lambda, so you will get lambda, so you will simply get lambda is 9 by 2, lambda is 9 by 2 you are getting. F prime 1 is 2g prime 1, so f prime 1 is 9 and g prime 1 is 9, okay, so lambda you will get this lambda. Okay, let's check that what lambda we are getting. So we are getting f prime minus g prime is lambda, so f prime x minus g prime x is lambda for some lambda that we can easily calculate given f prime 1 and g prime 1. Just check these values. Okay, now we are given again, if we can integrate, so we can write fx minus gx is lambda x plus mu, integrating this one. Then again given f2 g2, so I will write f2 minus g2 is 2 lambda plus mu. So I can find lambda and mu both. So function gets determined, fx1 is gx, right? So next step will be that we'll get fx minus gx is lambda x plus mu, where lambda and mu are known. So in fact you just have to find some value that is random values, that is just easy, that f3 by 2. So you'll just find f3 by 2 minus g3 by 2. You can find this 3 lambda by 2 plus mu. Once you get lambda mu, you can get this answer. This is easy. So this should be easy. If you do correctly, you should get 5 as the answer. Just check the answer later on. A previous year question, PYQ, easy, but then it must be done. Okay, this one is good. This one is saying that function fx satisfies the condition fx is x plus something. Then you want to know the function. Okay, so I will do like this here. F of x is x plus 0 to pi by 2 sin x cos y fy dy. So you write this as, the trick is writing that x plus, and see this depends only on y, so take out sin x outside. So sin x 0 to pi by 2 fy cos y dy. Now whatever this is, I don't know f, no problem, I don't know f, but this has to be a constant, lambda. So I will write fx equal to x plus lambda times sin x. Means in otherwise I know now what this is. I know that what lambda is, correct? What lambda can be means I know the form of the function. X plus lambda sin x. I have to get lambda now. So to get lambda, I will use this one, because lambda was 0 to pi by 2 fy cos y dy. So lambda is 0 to pi by 2 x plus lambda sin x, or sin y, you write lambda sin y cos y and dy. This we know, this one. So this is y, in fact, because I have written this one, so always written in terms of y. So this is y plus lambda sin y cos y. So let me do on the next page that lambda plus y sin y. So lambda equal to integral 0 to pi by 2 y plus lambda sin y plus lambda sin y cos y dy, correct. So I can write this as integral y cos y dy 0 to pi by 2, जिसको लिख सकता हूँ मैं lambda, इंटीग्रल इसको लिखता हूँ sin 2y by 2 dy 0 to pi by 2, right? This I can write. ये अब देखो ये आराम से आएगा. This will come easily, very easily. इसमें लिखता हूँ पहले y, इसको बाई पार्ट्स कर सकता हूँ, तो y टाइम इंटीग्रल cos y, so y times sin y 0 to pi by 2 and minus, or I can write directly only. So let me calculate here and write later. Y cos y dy is y times sin y minus sin y dy. So this is y times sin y plus cos y. So this I will write as y times sin y plus cos y 0 to pi by 2 minus lambda by 4 cos 2y 0 to pi by 2. So y sin y, this will be pi by 2, cos y 0, then if you subtract 0 it will be 0, and this is 1 by 2 minus 1, and minus lambda by 4 and cos 2y. So cos 2y, so I can write plus lambda by 4 and cos 2y, and I will write cos 2y. Yeah, I can change the limit 0 to pi by 2, change the limit. So this is pi by 2 minus 1 plus lambda by 4 times cos 0 and cos pi, so it is 2. So it is pi by 2 minus 1 plus lambda by 2 implies lambda by 2 is pi minus 2 by 2, and so lambda equals pi minus 2. So you have got y or x, fx is x plus pi minus 2 sine x. I hope this works. Just check this one. So you have to find this value, right? This was the thing. Let's check. fx is this one, satisfies this one. You want to find this one. So इसमें तुमने यही सीखा कि the form of function, this looks very much hopeless, no, that x plus something, but here we know the form of function, means we know that fx is nothing but x plus sine x, and 0 to pi by 2, 0 to pi by 2, and this one we are using, this one you are using, that this we are calling lambda because this is independent of xy, some simple value is there, so I am writing lambda and again put it back here to get what lambda is. Okay, any doubt? Okay, let's come to this one. Let f be a non-negative function, give a non-negative function on 0, 1. So that is justified, 0, 1. And twice differentiable in 0, 1. If 0 to x this is 0 to x this for 0, and if 0 is 0, then you have to find some limit. Some limit you have to find. So maybe I'll try to determine function first, that if I can determine function. So we'll write like this, that integral 0 to 1, integral 0 to x root 1 minus f prime t square dt is 0 to x dt is 0 to x ft dt, correct? 0 to x dt. अब क्या कर सकते हैं? You can differentiate them. This is 0, differentiate them. So if you differentiate them, you will get root 1 minus f prime x whole square, that's all, nothing else. And this is fx, right? So you will get this one. So I can write 1 minus f prime x whole square is fx square. So I'll get 1 minus fx square is f prime x square, correct? ऐसा आ गया. So I can write that root 1 minus fx whole square is f prime x, correct? अब देखो इसमें वैल्यू आ जाएगी ना, you will get value here. You will get f prime x upon root minus fx whole square. See, I am writing fx whole square to mean fx whole square, right? Sometimes notation use f2x also, but they will tell you sometimes f2x is also for f of fx, means it is also for say composition, but here I am squaring. Now this is 1, and so if you integrate f prime x by root 1 minus fx whole square dx, integral dx, right? So this will be f prime fx whole square fx whole square. So you will get this one, that this is अगर तुम put करते हो 1 minus fx whole square equal to 2, or fx equal to t, simply fx is 2. So you will get sine inverse of f of x is x plus lambda, this one, and given f0 is 0, so 0 equal to 0 plus lambda, so lambda is 0, and so you get sine inverse fx equal to x, and so fx you get as sine x, right? fx as sine x, so you get sine x. और अब पूछना क्या है, देखो यहाँ पे they ask something else. Limit h tends to 0 to x ft, limit h tend to, they ask you वो पूछ रहे हैं limit x tend to 0 x square integral 0 से x ft dt, correct? Check, this is what you correct, ft dt. तुम्हें इसी का वैल्यू निकालना है, तो ऑलरेडी तुम्हारा fx sin x आ चुका है. अब now you get sin x, तो limit x tend to 0 integral sin x f sin x and dt, so sin x dx 0 to x, or I will write sin t dt better, 0 to x, that is better notation, 0 to x sin t dt by x square, that is your limit. and that equals limit x tend to 0. This is sine x, and upon 2x, this is 1 by 2. So we'll get 1 by 2. Perfect. Anybody has any trouble? We'll get 1 by 2 as the answer. Let's check that what they're asking. They're asking this one, limit they're asking, so limit answer will be, limit answer happens to be 1 by 2. So you are seeing these all questions are really beautiful questions, and here you just apply differentiated with respect to x, Leibniz, many things you are doing. So all those will be asked in exam. So anyone who is seriously preparing, they should attempt these questions on their own. खुद से पहले करो, खुद से नहीं आने के बाद तब तुम check कर सकते हो मेरा solution, or you can check your own solution, or you can compare with other sources also. Normally you will find here method will be very good method, right? So you can solve like that. 1-2 homework also I will give. This we can do. This one. This looks like what? Looks like some perfect square thing, right? X plus 1 is square and other thing. Okay. So what this looks like is this, that x plus 1. So first it looks like a square 1 by a square minus 2, that is a minus 1 by a whole square. Correct? This is what we are getting, right? So root of, this is the first step, root of x plus 1 by x minus 1 whole square plus x minus 1 by x plus 1 whole square minus 2, that will be this one, x plus 1 by x minus 1 minus ये ऐसा आएगा ये, that is your 4x by x square minus 1. Correct? No need of tan theta, no need of tan theta, no need of tan theta. It is just pure algebra, does it simply and superb. So just this we get 4x by this one, root, no, if you take root also you get this one, root of this square, so you get this one, 4x upon this. Now, so now you are writing negative 1 by root 2 to 1 by root 2, and you are dealing with this one, so that is 4x by x square minus 1 dx. So I will take 2 out, I'll write 0 to 1 by root 2, so rather 4 out, 4 times 0 to 1 by root 2, right? Actually 2 will come 2 from here, right? Because it is even function, even. See, it is mod is there, mod x square minus 1. If you change x to minus x, you get negative x upon x square minus 1. That remains same. So earlier you could have broken, but not now. 0 to 1 by root 2, 4 is there, 2 to 4, and you will get 2x by 1 minus x square dx. This one, 2x by 1 minus x square dx. We can write like this. So this is 4 times, and this is ln of 1 minus x square minus 0 to 1 by root 2. Zero to 1 by root 2. So that is 4. I can change the limit. ln 1 minus x square, change कर दिया limit 4. So this is 4 times ln 1 minus x square, and this is 0 to, this is 0 will come up, 0 to 1 by root 2, that is give you 4 ln, this is 1, and minus ln 1 by 2, so you get 4 times ln of 2, so you can work, and so this is ln of 16, so ln for 16 is the answer. So you check, you will get ln of 16 is the answer. This you will get is the answer. Correct? So this was just making use of even odd function, which were evident, but you can, it's perfect square also. The high part was that it was perfect square. When we realize that, they will of course do it. Perfect square, that you can correct. Tan theta will not be good, you can check later. Okay, this you can try again, good problem. This same thing, it is okay. Now this one, that fx, f order satisfies this one, fx is this one. So we have got f of x is e to the power minus x sin x, ऐसा है sin x, and capital F has been defined as capital F 0 1 to r is defined as f of x equal to integral 0 to x ft dt, right? So you want f prime x plus x, so let's write f prime x. So f prime x is nothing but f of x, okay? f prime x is fx, या तो आ गया तुम्हारा ओके एफ एक्स. अच्छा ये तो अब इसको देखते हैं 0 to 1 में, तो इसको नेक्स्ट पेज पे करते हैं अपन. 0 to 1 एफ प्राइम एक्स प्लस एफ एक्स डी एक्स, ऐसा करना है, ऐसा करना है, ये है ना, दिस वन. तो ये कैसा आएगा तुम्हारा, ये एफ प्राइम एक्स ऑलरेडी तुम्हारा एफ प्राइम एक्स इज एफ एक्स, सी एफ प्राइम एक्स इज एफ एक्स है, तो एफ एक्स प्लस एफ एक्स विल बी 2 एफ एक्स. So you will write here 2 times 0 to 1 fx dx, ऐसा आएगा. fx is given to be 2 power e to the power x sin x, so this is 2 times, and e to the power x also was there, if I remember, e to the power x also is there. So this is e to this times you have got e to the power x dx also, e to the power x dx also. So 2 times 0 to 1, and you will get here e to the power minus x sin x, you will get e to the power minus x sin x e to the power x dx. So 2 times 0 to 1 sin x dx, so 2 times minus cos x 0 to 1, 2 times cos x 1 to 0, 0 to 1 here, so I can write 2 times 1 minus cos n, right? This is a good question, 2 times 1 minus cos 1. अब देखो ये बाउंड करना है, देख रहे हो, ये lies in the interval. They give many choices, right? They give many choices. So I will tell you this way that ये क्या होगा, जो अब तुम्हारा जब cos x होता है ना, cos x, when you write cos x, right? So you write 1 minus x square by factorial 2 plus x4 by factorial 4 factorial 6 and all those numbers you write, correct? ऐसा तुम लिखते हो cos x में, है ना? So what happens that cos x, ये ऐसा आता है, cos x is less than equal to 1 and cos x is greater than equal to 1 minus x square factorial 2. You can check this one, these things you can check. Cos x less than equal to 1, then greater than equal to this one, again less than equal to, right? So it will keep alternating between this one. You can just check that what holds. So this you can bound. So basically this all can be derived Oh, cos x will be actually this one that you are writing all of them. So okay, so you can have an alternate thing in negative positive cos x, and you have to find it. Actually this was to find a bound, lies later find a bound. So you can bound cos 1, you can write 1 here, and don't take all term, take only two terms and 3 terms. To find a bound. So you can find bound and you can answer this question about easily. This is again JEE advanced question 51, and I think it was again asked, so this is easy to work, you can work on it. This also is okay. I would like to do this one, maybe this one. This is first make that this is your this. Oh, this I left, but this you can do easily. This one better. This one is better. F prime is f prime 2 minus x, right? So from this one, that f prime x is f prime 2 minus x, इससे आपको क्या आएगा? तो from here you will get integrate this. You will get fx equal to minus of f 2 minus x. Minus of f 2 minus x. So you get f of x plus f of 2 minus x is constant lambda, and f0 is 1 given, and f2 is 1 square, so fx plus f2 minus x, you put this one, you'll get 1 plus e square lambda. So this you get, and you want 0 to fx dx. It's easy. So now you want 0 to 2 fx dx. Call it I. So I is also equal to 0 to 2 f of 2 minus x dx. So write 2y 0 to 2 f of x plus f of 2 minus x dx. So I is half of 0 to 2 fx plus f 2 minus x dx. That is half of, and this is 0 to 2, और ये आपका आ गया 1 plus e square dx, that we know, plus e square dx. So 1 plus e square is out, 1 by 2 is out, integral dx 0 to 2. So we'll get 1 plus e square. We'll get this only. Is that clear? Is that clear? We'll get this one, 1 plus e square. Just check. So they wanted some value. See, they wanted this only, value of 0 to fx dx. So again a JEE Mains question, beautiful question, but easy one. So lot many questions will be like that. तो तुम्हें केवल ये ट्राई करना है कि तुम इन my advice would be that check all the questions and try to find all these things which can be really worked. Normally it should be within your reach. I told you already the themes that what might be asked. So based on this you can all check it. So that's all for today. I'll connect with you later. You will get the notification and I will take up some different topic. Okay everyone, then thanks for listening, thanks for watching. Let's meet again.